Wait, I normally tell what video we're doing, or what the topic is, by our corners, but today I'm miffed. You've got a goat?
Yeah, and someone sent us some other tips for what video we're on. And they sent us some citric acid fruits and some rhubarb. So I think there's a link between the fruits, the rhubarb and the goat.
That's a good thing to make.
Whatever that link is what topic we're on in chemistry, so I'm stumped though.
Pie?
We had the same hint in maths to make pie.
Yeah. Probably not that though. I do like pie though.
I do like pie. Stuck in the other corner, there's a coo.
Pigeons go coo.
It's a carboxylic acids then, isn't it?
Yes, because unlike pigeons, goats have milk.
So we're on to carboxylic acids now.
Yeah.
Couldn't think of an intro, we did that.
So we did that, yeah. Our book's very helpful, tells you things that carboxylic acids are in.
Yep. So goat is an example, the milk from the goat is a hexacarboxylic acid.
Yep. Rhubarb has some carboxylic acid in it.
Citrus fruits. Ants, when they sting you, what they're putting in is ethanoic acid.
Which isn't that friendly actually.
No, it stings.
Ouch.
So, quick revision of what it looks like. We have drawn it up there, we'll draw it bigger.
Yep. So we have a C double bond into an O, bond into an OH.
You should be familiar with that from your AS.
You should. And if you watched our videos before this has appeared a few times.
Yep. In terms of naming it, this on its own, if this was a hydrogen, would be methanoic acid.
It would.
And that would be ethanoic acid.
You go on with your normal naming system from AS.
Yep, so if there was a methyl chain here, you still put the methyl bit first, so it would be 2-methyl propanoic acid. And I'm not going to go any further because, as Triv said, the rest is just the same.
Yeah. So, now we've got our thing, we want to know a few things about it. So first way, is it soluble?
Well, yes, to an extent.
Okay.
So, to be soluble, it's obviously being reacted in water. So if we draw up some water like this, we're going to have two molecules. These have lone pairs, don't forget, like this.
Yeah.
So what it's going to do here is the oxygen's going to form a hydrogen bond with the hydrogen in the water. And down here, what Triv's drawing is the hydrogen having a hydrogen bond with the oxygen of the water. That's going to make it soluble.
But as Wayne said, this only goes on for so long. It works for 1 carbon, 2 carbons in a chain, 3 and 4, but no further than that. Other than that, it just becomes insoluble.
Yep, and the reason is this part's soluble, but this part isn't. And when it gets beyond 4 carbons long, the insolubility outweighs the soluble part.
Yeah. So, like AS, we did other acids. This is an acid, needs to have its reactions.
Yep, it undergoes similar reactions to the others. So I'm going to go with, let's just make it easy and just have ethanoic acid.
Okay. So, the reaction we had in AS, we reacted with a metal, a
carbonate,
yeah, that's what I was
and a hydroxide.
Yeah, and some sort of base.
Yeah. So if we react this with sodium,
which is first our metal, basically what happens is it displaces the hydrogen, but it forms an ionic bond there.
Yep. And it's going to create hydrogen gas as well, so you're going to have effervescence, which is a lovely word. Yep, this is minus and that's plus to have an ionic bond there. And in the equation in the book it's a half H2. Alternatively you could have 2 lots of each of these, hydrogen gas.
But it would be all bubbly.
All bubbly. So how would you name this? Because it's not sodium ethanoic acid.
No. So first the carboxylic bit becomes ethanoate.
It's a salt, not a normal acid.
Yep, and you just put the sodium in front, it becomes sodium ethanoate.
And there you go. You could react it with sodium hydroxide.
You could. So if you did that, instead of forming bubbles at the end, it would just form water, but a similar thing would happen otherwise.
It's going to create the same molecule here, and just H2O. Because 2 of the H's come from here, it only needs 1 H, so it's not a half H2O. It's just that.
Yeah.
What was the other one? Carbonate.
Yep, finally carbonates, it will make the same thing as it did in AS, which is just hydrogen, no, water and
carbon dioxide with the usual product.
Yeah.
So, I'm going to bother writing it up.
But is it a strong acid, Wayne?
Carboxylic acids are weak acids. Think of ethanoic acid. It's an acid, a carboxylic acid, and it's weak.
And that's because it doesn't fully dissociate, but I'm sure you all know that already.
Yep, we did it in AS, so if you don't check that out. I think that's it for carboxylic acid.
I think it is.
Mostly revision.
So hopefully that helps.
revision.
Yeah.